In the massive race to win the electric car game, most automakers are playing by the old rules. They're all focused on batteries, charging speeds, and software updates, the loud, flashy parts of the EV revolution. But while everyone was looking one way, Elon Musk and Tesla were quietly building a revolution inside the revolution. They've rolled out a motor technology that isn't just an upgrade, it's a total rewrite of the rulebook, and it's leaving the competition in the dust. What if a simple-looking motor, one that a single person could carry, could smoke million-dollar supercars and completely redefine the limits of automotive engineering? So how did a simple idea, a carbon-wrapped rotor spinning at over 20,000 RPM, just change the EV industry forever? We're about to pull back the curtain on the secret behind Tesla's insane speeds, its mind-boggling efficiency, and what this quiet breakthrough means for every single electric car from here on out. For years, the story we've been told about EV progress has been all about batteries. We got obsessed with range, charging times, and that nagging fear of running out of juice. The whole industry, from the old giants to the new kids on the block, got locked into a war over kilowatt hours and charging stations. And look, that stuff is important, but it created an illusion that the battery was the only thing that mattered. While car companies were dumping billions into battery tech, they were mostly ignoring a ticking time bomb at the heart of the car, the electric motor itself. The motor was seen as a solved problem, a mature technology. But in reality, it was the silent bottleneck holding EVs back from their true potential. To get why, you have to understand the brutal physics going on inside one of these things. Picture a heavy donut made of copper and powerful magnets spinning at an impossible speed. Now imagine that donut is desperately trying to tear itself apart from the inside out. That's the challenge every motor's rotor faces. As it spins faster, the centrifugal force gets so intense that the materials start to stretch and warp. To keep the rotor from literally exploding, old-school motor designs wrap it in a metal sleeve, usually made of strong steel or a fancy alloy like Inconel. This works, but only to a point. That point is usually around 16 to 18,000 RPM. Go faster and the forces are just too much. The metal sleeve can't hang on and the motor is at risk of blowing itself to pieces. So that 18,000 RPM limit became an invisible wall for the entire industry. But the problems didn't stop there. These strong metals are also great at conducting electricity. As the rotor spins inside the magnetic fields of the motor, that conductive sleeve creates something called eddy currents. You can think of them as electric friction. They don't do anything useful, they just create a ton of waste heat and suck the life out of the motor's efficiency. This left car designers with a frustrating choice that defined a whole generation of EVs. You could build a motor for insane, face-melting acceleration, but it would overheat fast, and the car's computer would have to cut the power to prevent damage. Or you could build it for high efficiency and long range, but you'd lose that top-tier repeatable performance. You could have one or the other, but not both, especially at high speeds. Every automaker was stuck on this seesaw, trying to find a balance. It wasn't just a design challenge, it felt like a law of physics they just couldn't break. While everyone else was trying to manage the heat and stress of their metal-sleeved motors, Tesla decided to just change the game. They looked right at the source of the problem, that metal sleeve, and asked a simple, brilliant question. What if we just got rid of it? The answer is the carbon-wrapped rotor, which made its debut in the powerhouse Model S Plaid. This piece of tech is so elegant and so clever that it's easy to overlook how important it is. But make no mistake, this is probably the biggest leap in electric motor design in a generation. So what is it? Instead of holding the copper rotor and magnets together with a metal sleeve, Tesla figured out how to wrap them in an incredibly thin, just 0.5 millimeter thick, but unbelievably strong jacket of carbon fiber. And this isn't just any off-the-shelf carbon fiber. It's spun onto the rotor using a custom-built, highly advanced machine that puts the fibers under extreme tension. This is the secret sauce. Winding the carbon fibers so tightly puts the rotor in a constant state of compression. It's like squeezing that donut with an unbreakable grip before it even starts spinning. As the motor speeds up and centrifugal force tries to make the rotor expand, it first has to fight against that immense preload from the carbon wrap. The strength of this carbon fiber is off the charts, around 7,000 megapascals, which is more than 5 times stronger than the steel used in competitor motors. Now, this tech didn't just appear in 2026. It first showed up with the Model S Plaid back in 2021, but the real industry-shattering impact of it is only being fully understood now, as years have gone by and no competitor has managed to match its blend of raw power and efficiency. It was a silent revolution, and the aftershocks are now reshaping the entire car world. By swapping the metal sleeve for an insulating carbon fiber one, Tesla scored 3 game-changing wins all at once. First, that RPM barrier was completely shattered. With the carbon wrap holding everything together, the motor can now spin at speeds over 20,000 RPM, and some versions might go even higher. This isn't just a small step up, it's a jump into a performance zone that used to belong only to multi-million-dollar hybrid hypercars. This insane RPM is the secret to the Plaid's relentless, never-ending river of power that just refuses to quit even at ridiculous speeds. Second, those annoying eddy currents? Gone. Carbon fiber is an electrical insulator. By getting rid of the conductive metal sleeve, Tesla eliminated the main source of waste heat that plagued older motors. The new motor runs dramatically cooler, even when you're driving it like you stole it. This means the performance doesn't fade after a few hard launches. The power is always there, whenever you want it. And as a huge bonus, killing that electrical friction makes the motor way more efficient, turning more of the battery's juice directly into motion. Third, the motor got way more powerful for its size. That old metal sleeve didn't just create heat, it was a physical barrier that forced a bigger gap between the rotor's magnets and the stator's windings. By using a super-thin, non-conductive carbon sleeve, Tesla could shrink that gap, creating a much stronger, more focused electromagnetic field. This is the holy grail of motor design, a massive jump in power density. It lets you build a motor that is smaller, lighter, and yet way more powerful, hitting power-to-weight ratios that engineers used to only dream about. This single elegant fix didn't just improve one thing, it solved the problems of strength, heat, and power all at the same time. It broke the trade-off. All this theory is great, but the proof is in the pavement. And the ultimate proof is the Tesla Model S Plaid, a car that's basically a paradox. It's a quiet, normal-looking 4-door family sedan that can, without any drama, absolutely humiliate purpose-built multi-million-dollar supercars. Let's just look at the numbers, because they're frankly absurd. The Plaid's 3 motors, all using this carbon-wrapped tech, pump out a wild 1,020 horsepower. At the wheels, this translates to a torque figure that gets incredibly close to 14,000 newton-meters, a number you'd normally associate with a fully loaded semi-truck. All that power means acceleration that feels less like a car and more like a teleportation device. 0 to 60 miles per hour is a claimed 1.99 seconds. Now, to be perfectly accurate, that number is measured with a 1-foot rollout, which is standard practice in car testing. The true time from a dead stop is closer to 2.1 seconds, which is still jaw-dropping for an over 4,800-pound sedan. It demolishes the quarter mile in the low 9-second range, a feat once reserved for dedicated drag cars that you had to trailer to the track. But here's the most important point, the one that gets lost when people just focus on 0 to 60 times. The Plaid's real magic isn't just that it can hit these numbers, but that it can do it over and over and over again. Other high-performance EVs can give you a couple of breathtaking launches before their motors and batteries get too hot, forcing the car to cut power to protect itself. The Plaid, thanks to the thermal efficiency of its carbon-wrapped motors, just doesn't have this problem. The lack of waste heat from eddy currents means the motors stay cool, even under repeated, brutal acceleration. This isn't some fragile one-trick pony, it's a consistent, reliable monster. And this is where the paradox becomes a revolution. This relentless performance doesn't kill its everyday usability. The Plaid hasn't sacrificed its range to get all that speed. Because the motors are so efficient, the car still has a very respectable EPA-estimated range. It completely shatters the old rule that insane performance must come with terrible fuel economy, or in this case, terrible battery drain. The carbon-wrapped motor lets the Model S Plaid be two completely different cars at once. It's a comfortable, long-range daily driver and a world-beating performance machine all in one. It proves that with the right core technology, you don't have to choose between speed and sustainability anymore. So, what does all this mean for the competition? The Plaid's capabilities sent a shockwave through the engineering departments of every other car company. While brands like Porsche and Lucid have built some truly fantastic and capable EVs, they're still, for the most part, playing by the old rules. They are perfecting a strategy that Tesla just made obsolete. Let's be fair and give credit where it's due. Lucid, for example, has engineered motors that are incredibly efficient, sometimes even more so than Tesla's in certain metrics. Their cars have some of the longest ranges on the market, which is a testament to their brilliant work. Porsche, with the Taycan, focused on world-class cooling and a clever two-speed gearbox to deliver consistent performance. But here's the key difference. Tesla's carbon-wrapped motor isn't just an improvement, it's a fundamental change in the physics of the motor itself. Lucid's motors are super efficient, but they don't have that 20,000+ RPM headroom for the kind of relentless, high-speed power the Plaid delivers. Porsche had to engineer a complex, heavy, and expensive two-speed transmission to do what the Plaid's single-speed motor does effortlessly, give you both a brutal launch and extreme high-speed power. Tesla solved the hardware problem with better hardware, while competitors are still trying to solve it with more hardware. Maybe the scariest part for competitors is that this tech is a huge manufacturing challenge. You can't just call up a supplier and order a carbon-wrapped rotor. Tesla had to invent, design, and build the proprietary machine that creates these motors. This do-it-yourself approach is a core part of Tesla's strategy. It means a rival can't just take the motor apart and copy it. They'd have to reinvent Tesla's entire manufacturing process, a massive job that could take years and billions of dollars. This creates a clear divide in the industry. Tesla's no longer just competing on specs, it's competing on fundamental physics and manufacturing science. While other companies were benchmarking each other's 0 to 60 times with old motor designs, Tesla was rewriting the textbook on how those motors should be built in the first place. This one component created a technology gap that many rivals are only now starting to understand. The true genius of the carbon-wrapped rotor isn't just that it made one insanely fast sedan. Its real impact is how it can be scaled and what it means for Tesla's entire future, from exotic hypercars all the way down to affordable family cars. First, let's talk about the long-awaited next-gen Roadster. The unbelievable specs promised for that car, 0 to 60 in 1.9 seconds without rollout, a top speed over 250 miles per hour, and 600 miles of range, are only physically possible because of this motor technology. The Roadster will almost certainly use an even more advanced, higher RPM version of the carbon-wrapped motor to handle the extreme forces needed to hit those numbers. Then there's Tesla's Semi. While the Semi uses different, larger motors built for hauling, the engineering philosophy comes straight from the Plaid program. The lessons learned from making hyper-efficient, thermally stable motors that can run under constant heavy load are what will allow the Semi to hit its ambitious target of using less than 2 kilowatt-hours per mile while hauling 80,000 pounds. It's all about a culture of pushing motor efficiency to its absolute limit. But the most important impact of this tech has nothing to do with supercars or big rigs. The real endgame, the reason this motor will change the world, is how it affects affordability. The dream of a truly mass-market, affordable EV, the so-called Model 2, depends on innovations just like this one. Here's why. The power and efficiency of the carbon-wrapped motor create a waterfall of cost savings. A more efficient motor needs less energy to go the same distance. That means you can get the range you want with a smaller, lighter, and most importantly, cheaper battery pack. The battery is the most expensive part of an EV, so any reduction there makes a huge difference in the car's price. And a lighter motor and battery means the rest of the car, the frame, the suspension, the brakes, can also be made lighter and cheaper. While the exact timeline for Tesla's low-cost car has been a moving target, the technological path to making that car profitable is paved by innovations like this one. The ability to get great performance and range from a smaller, cheaper powertrain is the key to cracking the sub-$30,000 EV market. Now, this is where a lot of people get confused, and it's a really important distinction. Many people mix up two different, groundbreaking motor projects at Tesla. The carbon-wrapped Plaid motor is a mechanical revolution designed for incredible strength and speed. But it is a permanent magnet motor, which means it still uses rare earth metals like neodymium. Separately, Tesla has announced they are working on a future generation of motors that will be completely free of rare earth metals, probably using ferrite magnets or some other tech. These are two different solutions for two different problems. The carbon wrap solves the physics of performance. The rare earth-free design will solve the cost and sustainability of the supply chain. The fact that Tesla is working on both at the same time shows you how far ahead they're thinking. For more than a decade, the EV story was all about miles and minutes, how far you could go and how long it took to charge. But the carbon-wrapped rotor starts a new chapter, one written in revolutions per minute. This wasn't just another small improvement, it was a breakthrough that solved a core physics problem that was holding the entire industry back. It unlocked a new level of performance, not just in raw speed, but in its relentless consistency. It shattered the old compromise between insane power and everyday efficiency, proving you really can have it all. And most importantly, it gave Tesla a deep structural and technological advantage, one built not on marketing, but on a mastery of material science and manufacturing. While everyone was busy fighting the battery wars, Tesla was quietly winning the motor war. This one innovation didn't just give us a faster car, it redrew the map for the entire auto industry and set a new benchmark for what's physically possible. The silent hum of the electric motor just got a whole lot louder, and its sound is the roar of a revolution that's already happened. The real question isn't if others will catch up, but how long it will take them to realize the race itself has changed forever. If you enjoyed this look into the engineering that's shaping our future, be sure to subscribe and hit that notification bell. We're always exploring the tech that's changing our world. Thanks for watching.